streaming. This is again, I'm a singer, eternal voice. Now our topics, because there are two topics to be discussed at this moment. Okay, so we have the gravitational force and the force of electric force between protons and electrons. Okay, something like that. Okay, so the first we need to discuss the gravitational force. But before that, I forgot, we need to classify and categorize forces first. Okay, what are the four types of forces? Anybody? Anybody? So the four types of forces are, okay, four types of forces. So when we talk about force, what comes in our mind? It always linked with a pressure, right? Pressure is equals to force over area, something like that. And pressure is directly proportional to the force. Okay, if there's a pressure, then there must be an applied perpendicular force to any object or any material to move, something like that, right? In that particular surface area. That's why P is equals to F over A. But in this perspective, it talks about more on the subatomic particles and in the, in the larger scale. To say in the universe. Wow. This is also part of planetary science. Okay, so as we can remember in our elementary education, right, our teachers taught us that there are 12 planets revolving in the center of the sun, something like that, right? You still remember, and one orbit, okay, like that, it will travels one revolution, and while it travels in the orbit, while it revolves, it will also rotate simultaneously in each orbit, something like that. And then these planets will not falling downward because of gravity. Okay, that's why gravitational force. There's gravity involved. Okay, so the first force we need to discuss, of course, gravitational force. Okay, gravitational force. Okay, like this. So gravitational force. This one, guys. First type of force, the gravitational force. So this is, if we talk about classical mechanics under physics, this is particularly the third law of Isaac Newton. Three laws of motions, right? That in every action, there is always equal and opposite reaction. Okay, so this is the third law of Isaac Newton. And then gravitational force, of course, the gravity. So we can connect that to the acceleration due to gravity, something like that. And the values are 9.81 meter per second squared. Okay, and this is very basic in physics. This has been discussed all the time, especially dealing with motion. Okay, motion, speed, velocity, acceleration, something like that. Okay, the projectile, the trajectory, something like that in physics. So this will be always discussed. So 9.81 meter per second squared. This is a metric system, and we also have English. This is English, right? 32.2. Okay, 32.2 feet per second squared. Okay, so if we speak about acceleration due to gravity, so this must be linked with a gravitational force. Okay, but the only difference, this two acceleration due to gravity constants will be applied only inside the planet Earth. You get the point? There's a limitation. You can apply this in the universe. Okay? When we discussing in a larger scale, such as the universe, like that Milky Way, galaxy, in which there are a lot of planets there. Okay? Asteroids, comets, okay, something like that. Okay? And a lot of stars, moons, like that. Okay, so that's special for planetary science. The gravity there is no longer 9.81 meter per second squared and 32.2. There's another specific value of the gravitational constant, which is the Newton gravitational constant, which is equal to, then this is designated as capital G. Okay, so we need to know the limitation, where to apply. Okay, so that in the problems, for example, if the problem will say, what is the distance between the Mars and the Earth towards the Sun, something like that, and you're still using the 9.81, okay, it's no longer applied, that kind of gravity. That's only inside the planet Earth. Okay? You get the point? So, for example, your mass and your weight will not be equal when you are in the moon. Okay? Something like that. Okay? So, the gravity will matter, something like that. But in here, the gravitational force constant, Newton na siya ha, Newton gravitational constant to make it precise. Actually, we can say also gravitational force constant, but discovered by Newton. Okay, so anyway, Newton also extended his discovery in the universe, not only to the, limited to the classical mechanics or the three laws of motions in physics, right? So capital G, okay, capital G. Oh my gosh, it confused me also for the Gibbs free energy in thermodynamics, second law of thermodynamics. Yes, okay. But G man sad siya, di ba? So, anyhow, this is the topic of planetary science. It's put this in this way, okay? Just forget a little bit with thermodynamics because gives free energy also is capital G in thermodynamics, okay? Now the G is a constant here, equal to 67 times 10 to the negative 11, okay? Newton. See? Because he discovered this, the unit also have Newton. Okay? So Newton meter squared kilogram squared. Okay? Like this. Because he discovered this, the unit also, the constant also have the Newton. Okay? Something like that. So now the formula of the capital F for the gravitational force in planetary science. So we have this capital F. Memorize this, guys, ha? Capital F, especially to those who are, taking the board examination. Okay, this coming October. Okay, shout out sa mga BS Chemical Engineering graduates who prepared for the board examination. Okay, gravitational force capital F is equal to, okay, like that. So capital G. Okay, like that. Like this. Mass 1, mass 2 over r squared. So actually, guys, this is a general formula for the gravitational force in the universe. Okay, this one. Okay, but this sounds to be hypothetical because mass 1 and mass 2 only. So we don't know yet if these are the mass of Saturn, mass of Jupiter, mass of the Sun, mass of the Pluto, mass of the Mercury. We don't know yet, right? Because it's only designated 1 and 2. So it depends on the problem na talaga siya. Okay, which are considered. But let's just designate this. M1 is the mass of the Sun. Okay? Because the mass of the Sun will always be mentioned in the gravitational force because the Sun is the center in the universe. Center, but at the side of the foci. You know foci? F-O-C-I. Okay? Meaning the plural of focus. Just like fungi, the plural of fungus. Something like that. Okay? Virus, ganon, viral. So, in English, foci is the plural of focus. So, our focus will be in the center. And this sun is somewhere along at the side, but still in the middle. Okay, not really technically precise na at the center, but in the side of the foci. Okay, like that. So I will draw later on so that we will understand also based on the illustration. Okay, so let M1 as the mass of the sun. Okay, so in here, guys, this is the topic that we can calculate the mass of the Earth. Okay, the mass of the Earth, the mass of the, okay, Saturn, all the planets' masses we can compute. Okay, something like that. Because we have data from the previous scientists. Okay, from Johannes Kepler and again Isaac Newton. Okay, then after 19th century, 20th century until now, there's no such latest discovery for that standard. Okay, so meaning to say, we don't have updated mean distances between the planet and to the sun, what we call as the semi-major axis in the orbit distance. Okay, our basis is always the sun. Okay, something like that. And until now, we don't have scientists at the present that discovered the distance of the Earth to the sun, the distance of Uranus to the sun, or any kinds of planets distances to the sun. So that's why we keep always using this data from our old scientists. You get the point? So meaning to say, they are more brilliant compared to the modern days. Okay, our old people are more brilliant compared to our people today because our people of today are only developing, improving the new technology in which the basis for the theories, concepts, and basic foundations were derived from our old scientists and our previous scientists in 16th century, 17th century, 18th century, 19th century. 18th century only because 19th to 20th it stopped. Really, they keep on modifying only, improving only, but no new discovery. Okay? The main basis for that, guys, is that in the schools, in the schools, in the universities, in the institutions, that we have books, right? The books we have, it should be reflected there if there are new scientific discovery because it will be taught in the curriculum of a certain educational platform. Okay, but until now, there's no such like that. Okay, because no one dares also to measure the distance from the Earth to the Sun, of course. Okay, they are doing the NASA, United States of America, they're doing another thing, not not the technical aspects of the measurements. They're trying to discover another thing, okay, not this type of, technical information regarding the planetary science in the universe. Okay, imagine, okay, that was 18th century and now in 20th century, so there's no latest discovery for that. And we keep on using that until we will die. And we need to, to transmit and to, give this knowledge to our younger generations. And they will also keep using that one. Okay, so it's just only a cycle. We will disappear, we will vanish in the planet Earth, another will come out, another will evolve, the new generations, our future generation by our future children. Okay, that's why things like this, sharing of academic information in social media, is very important also. Okay, because we need really to share, we need really to give to them, okay, our knowledge because it could not be denied, we will die. Okay? Okay, we will die. We will never reach 200 years old. We will never reach 110 years old. We will never reach 100 years old, and let's accept that biological fact, whether we like it or not. Okay? Something like that. So that's why we need to educate our younger generations. Okay? So things like this is an example of sharing science academic information to our future generation. Okay? Going back to the gravitational force. Okay. Now, M1, we left that as the mass of the sun. Okay? M1, the mass of the sun. To make it specific, right? We need to declare Because if you don't declare, that's hypothetical, meaning it doesn't declare anything, right? Okay, the mass of the sun. But the formula, based on my research, is not really specific also. So I need to, establish my own attack on how to discuss in front of you to this particular formula also. Okay, having my stack knowledge, something like that. Also having my knowledge in my education also in BS Chemical Engineering, something like that. So because they are not also spoon feeding everything in the books. Okay? There's no spoon feed discussion. Even though you will find also in the YouTube, not spoon feed, wala gihungit tanan ba? So you need also to find out. Sometimes automatic only, you don't know, oh, where does it come from? Something like that. And again, you will go to another sources like this. It's a source of, it's a little bit of effort in your part, something like that, okay? And to be, shall we say, to be resourceful. Okay, the mass of the sun. Okay, M2 is the mass of the earth. Okay, mass of the earth. Okay, guys, the small r, or we can say this as a capital R, it doesn't matter, right? Because R also stands for the mean distance or the semi-major axis in the orbit. Okay, so distance lang give it a shot. Okay, so G, gravitational constant is here already, right? Then you can solve for the gravitational force immediately. But the case is not like this always. Okay, it's not really direct substitution all the time in the problem solving. And we need to think with so much correlation. Something like, for example, this one, guys. This one, gravitational force in the universe. Sometimes also, they will put this as masses of electrons, protons, like that, because it can also be happening in the universe. There's also protons and electrons there. Okay? Subatomic particles. The study of subatomic particles is the evolution of the universe. Okay, something like that. So it was really the discovery of the Big Bang Theory. Okay, in 18 billion years ago. Ganon. Big Bang Theory, okay? So the evolution of the universe is through Big Bang Theory 18 billion years ago. Okay, something like that. 18.3 or something like that billion years ago. Okay, basta ganun na siya. So, for example, the examination will state which is a theory that states that the evolution of the universe is happening 18 billion years ago. A, blah, 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 Arrhenius theory, blah, blah, B. The answer will be Big Bang theory. Okay? So, something like that. So, we have now the F. Now, guys, I will draw now the orbit, the universe. Oh my gosh. Miss Universe 2018 goes to Catriona Gray from the Philippines. Charot. Okay, like this. Universe. Okay. Sorry guys that my illustration is not perfect. Okay, it's just like this. Actually guys, our planet Earth is not really that circle. It's just like a little bit of elliptical already due to various harmful gases exists in the atmosphere and other different substances also. Okay, because our planet Earth is very old already. Okay, something like that, and it reaches to about 3 billion years old plus, based on my research. Okay, our planet Earth is already 3 billion years old plus, based on my research. Okay, something like that. So how old is our planet Earth already? So sometimes ellipse na siya. Okay, just like a little bit of oblong, not the circle. Okay, like that. So it's wrong to say the planet Earth is round. It's not really that round. A little bit of elliptical. Okay? Something like that. A little bit meaning slight. Okay? I'm not saying oblong or whatever, chuba chuchu. I'm saying only a little bit or a slightly elliptical or ellipse. But not a perfect circle already. Okay? Our planet Earth now. Okay? Something like that. It could be on the vertical or the horizontal, something like that. Okay? But what I'm telling is not 100% circle. It's not 100% round already. Okay? So, these are the orbits in the universe. Okay? And then we have the sun here. That's why I told you in the center of the foci, one side of the foci. Okay, like that. Okay, this is the, let's just take it to an example only. I don't have to draw the 12 planets, right? It's very, too much tasky to illustrate all. I only draw the planet Earth, of course. Okay, for example only, because we know that the Mercury is the nearest planet to the sun. But this is just only for the discussion. I have to put the planet Earth in the first orbit. Okay? Discussion lang niya siya. Good. Okay. Okay. This one. This is I told you. Okay. The sun is the center, but at one side of the foci. Meaning to say, it's still also in the center, but not really perfect in the center. It's on the other side. Okay? And the planet Earth is rotating in that orbit. Okay? And then, the distance from the Earth to the Sun is this the R in this formula. Okay? So, we will draw this as R. Okay, ganon. R. Like this. Do not interpret this as a radius, This is only R, distance, mean distance, okay? Because usually in algebra and trigonometry, we interpret R as the radius. Okay, but here it's not. It's the distance, mean distance, or the semi-major axis of the orbit. Okay, something like that. So it's gonna be like that, okay? It's very clear. R. Okay, now guys, since this is also round, round? Okay, round is not literal. When we speak about round, it could either be a little bit oblong, a little bit ellipse. So it doesn't mean that if we speak round talaga, perfect round talaga siya. Okay, it's still round, but not that perfect circle. So this is where the concept of centripetal force will be applied in physics. Okay, centripetal force is the opposite of centrifugal force. Okay, because the centripetal force is the force directed toward the center in the sun. Or if we refer that as a nucleus, it is the force directed toward the nucleus. But this centrifugal force, it is a force applied away from the nucleus, or it is a force applied away from the sun. Okay, it is varying in the different reference. Our first reference is the nucleus, and our second reference is the universe. Okay, but it's still having the same analogy and principle, outward and toward. Okay, English. Toward meaning going there. Okay, outward meaning away. So again, this is adjective, something like that, to describe the specific distance among objects or whatever. Okay, something like that. Okay, now, as we can remember in our physics, okay, the formula of centripetal force, we're not dealing with centrifugal force, guys, because we are not talking about the away forces. We are talking for the toward forces in the center of the universe. Okay, this is the reason behind we don't talk about centrifugal force. Okay, we are talking of centripetal force. Okay, Fc. Okay, centripetal force is represented as Fc, capital F, subscript, small letter c. Okay, so Fc. So ganito yung formula niya in our physics. This is the mass times the velocity squared over the r. Again, this r here is the distance also. Okay? Something like that. Now, so we need to have equation that will always parallel among the two. So again, this is very important in science. We need to take this in equilibrium. Okay, because FC also are applying the principle of circular motion or elliptical motion or round, something like that. And this gravitational force also are elliptical and a little bit round. So they are parallel with each other. You can only equate or you can only have a ratio and proportion if you are trying to have the same quantity, okay, or the same parameters, the same operating conditions to be considered. If not, you will not be able to have parallelism. You don't have to equate point 1 to point 2, and you don't have to undergo ratio and proportion formula in algebra. Okay, so these things will be always kept on using until you will go your higher subjects in engineering courses. It's gonna be like that. The purpose only is to simplify, equations, formulas, and to cancel out units. So we are only after for the equation and formula to be, specified and specific and simplified. Okay, in order to quantify easily, okay, in order to be measurable, we need to have a formula on equation that is quantifiable, of course, measurable, specific, something like that. And most of all, not complicated part, specified, okay, something, and very, very easy to understand and in a simplified form. Okay, that's why we have derivation. That's the purpose for that. Okay, derivation of formulas and equations in mathematics and science. Okay, going back. So now, let's equate the gravitational force and the centripetal force. Since I use the word equate, the root word is equal in English. So I have to put two lines, right? Equate. Oh, ganon. So F, gravitational force, let's just have that as Fg. Capital F and subscript capital G. Okay, is equal to capital F subscript capital C. On this one. Fg is equals to Fc already. Okay guys, now in centripetal force, this is not referring to the sun in the universe. This is referring to the somewhere in the planets. So since I considered Earth here in my introductory discussion here, Earth and the Sun, now I will also introduce the mass of the Sun in the equation of the centripetal force in order to parallel of the quantity that I used in the gravitational force equation. So that's to simplify it again. Okay, something like that. Okay, alangan magagamit ako Saturn and the other one is Earth. So it will confuse us. Okay, something like that. So I could say na G is equals to mass of the Sun times mass of the Earth. Okay, divided by the semi-major axis of the orbit or the mean distance r raised to the power 2 is equals to the mass of the Earth, okay, times the velocity raised to the power 2 over r. Ganon. Okay. You see the formulas? Guys, centripetal force is circular, right? So, in this manner, we will use also angular. Okay, angular velocity, angular speed, angular momentum, right? So the V here is referring to angular velocity. Okay, so when we mean of angular velocity, what comes in our mind, it's an expression, a ratio between the distance over the time. Okay, now since we are referring to an elliptical orbit or around round, a little bit round in shape. So we will never use the regular distance that we acquired in physics, right? The second law of Isaac Newton. Okay, force is equals to mass times acceleration. We will never use that one. I will never use also that kind of velocity, distance over time, or displacement over time. We'll never use that one because it's for horizontal, going left, going right. Okay, but here is round shaft. So we will use the circumference as equal to our distance, something like that. So what is the circumference of a circle? Okay, algebra. Anybody? So we need to review the area, the circumference of a circle, or a little bit orbit or something like that. Okay, ellipse. Okay, so our circumference, guys, is 2 pi r. So this will be our distance, okay, in the universe. Where's the universe? Oh my gosh, it's in here. Okay, so the centripetal force will be somewhere along here. See, it will be directed to the sun. Ganon. FC. Okay, so ganun siya. Where's the formula again? Okay, C 2 pi r. So it will now become 2 pi r over t. Okay, so angular velocity or v in circular motion or in orbit in the universe is equals to 2 pi r over t. Okay, so we're gonna substitute this v in our equation at the top. Okay, but let's simplify it first before substituting this value of v so that there will be no confusion, where to cancel. Sometimes also it will confuse us. So let's simplify it first before substituting values, right? Okay, now, as you can see here, guys, what are the quantities to be cancelled? So you need to look what are the similar quantities. Okay, in here, there's a mass of Earth in the left, and there's also mass of Earth in the right. So you have to cancel the mass of the Earth. Okay, like this. Malo? Okay, now, in the left and right also, take a look in the denominator. There's also common, the radius. We need to cancel the r in the other side, in the centripetal force formula. And what's left is the r in the left, in the gravitational force formula. And now, let's do again algebra. Okay, the crisscross multiplication method. Okay, rule in algebra. Okay, so like this. Okay, so you need to multiply that side by side. Okay, put an x. The x there is a direction where to multiply. Something like that. So this gonna be, guys, if there's no more letter here, that could mean 1 in algebra. Okay, not necessarily to put 1. That could mean 1 already. Okay, so this is gonna be g times gravitational force constant times the mass of the sun, okay, is equals to the velocity squared, ganon, times the radius. Oh, this is gonna be like this. Okay. Okay. Now, guys, in an equation or in a formula, we need to solve for one quantity lang yun siya. Okay? So again, para way malubog, in the rule of algebra, we need to multiply each term in which it has the coefficients. And so that it will cancel, what will remain is one quantity. Always like that in mathematics. Okay? So that only one variable to be remain in order we can find out the value of that variable. So we need to cancel out that one also, and we need to check what's gonna be the variables to be divided, what the variables to be multiplied with, so that it could be simplified further. Okay, something like that. So in here we need to simplify it further, so we need to divide this by r here, because we need to compute for the velocity. right? So there's still r beside the velocity as coefficient. Okay? So we need to divide this by velocity kaya mulubog ang r. Okay? So divide. Okay? R. So again, what's the same? Similar quantity cancels that out. Okay? Balik ra gyud siya, guys. Okay? Mao gyud siya technique sa mathematics. Okay? Since elementary to college, it will never change really. Okay, crisscross multiply, cancels out, simplified, equilibrium, like this. It's always gonna be like that. So that's why you need to have the basic foundation. Okay, so it should be cancelled. So what will remain? V squared is equal to G times ms over R. ms is not mass, ha? ms means mass of the sun. Nagkataon ra siya. Okay? So it's gonna be V squared G mass of the sun over R. Now this is the time, guys, we need to substitute for the value of the angular velocity in which we have here. Okay, so substitute. But before substituting that one, we have an exponent V squared. We don't want that also in mathematics. In mathematics also, if there is an exponent, we need to eliminate that one to solve for the variable alone without any exponent at all. So that's also a technique. And then we will multiply both sides also by a certain fraction to eliminate that exponential form. Ganon. So this is V squared is equals to gravitational force constant times the mass of the sun over R. Then there's raised to the power 2 in the velocity. We don't need that 2. Okay, so we need to multiply these quantities left and right with 1/2. Okay, so that the 2 will be eliminated. It will become V. Okay, something like that. So 2 times 1/2 is equals to 1. So this is equal as V or angular velocity alone. So bingo, simplified na talaga siya. No exponent, why nilubog na tupad. Okay? So V. Okay, something like that. And now, GMS over R raised to the power 1/2. Okay, how can we do this? Guys, in mathematics and algebra, if we raise that to a certain 1/2, that's equal to square root. Okay, square root. And if it raised to 1/3, that is cube root. If it will be raised to 4, that is 4th root, 5th root, 6th root, 7th root, 8th root, until infinity. Okay? You get the point? Okay, until infinity, meaning walang kamatayan. Okay, infinite. If you will just follow the pattern and the series of that exponential pattern. Okay, starts with square root. Okay, cube root, 4th root, 5th root, blah blah blah, so and so, chuva, chuchu. Okay, square root of G ms over R. Okay. So this is our simplified now formula of the velocity. Okay. For example, if the problem will say, what is the velocity of the Earth, okay, traveling in an orbit towards the Sun with a distance of, for example, only ay tinud example only, okay, with a distance of 82 million miles away. Ganon. So you can compute already. Okay, something like that. So, what is the mass of the sun? Ganun siya. Okay, because there's constants man siya. So, the purpose of the constants is to help to solve the problem. Okay? Okay. Mugamay ang given. Ang mudaghan ang given, then you can solve easily what is being required. Okay. Now, what is the value of V? We are not yet still substituting the value of V here sa centripetal or sa circumferential velocity or angular velocity. Now it's gonna be V squared over GMS over R. Okay, arita diri mo substitute to the V squared is equal to GMS over R, not in the square root part, because it's very difficult to substitute this angular velocity in the square root part. Okay, so we are going to the V squared is equals to GMS R. Okay, so substitute the value of 2 pi r over t to the velocity squared is equals to gms over r. So it's going to be like this, 2 pi r over t parenthesis, okay, raised to the power 2, and then gms over r. I think it's going to be a polynomial. No, not yet. Okay, this is not a polynomial, sorry. Okay, this is still linear. Okay, so 2 pi r linear equation. 2 pi r times 2 pi r. So there's gonna be 4 pi squared r squared, right? Because 2 pi r raised to the power 2. And then t raised to the power 2 is simply t exponential 2. Okay, something like that. So 4 pi squared r squared small letter t, okay, is equal to g m s r. Okay, ganon. Lawa guys. Okay. Now, this is our equation. Again, crisscross multiplication. Makakita ganin mag-equal sa tunga-tunga. So, crisscross multiplication, yun na siya. Okay? So that it made us easy in our derivation. Okay? Something like that. So, we don't have to worry class because this is not involving calculus. Okay? So we can manage because this is purely mathematical operation, the basic operations. Okay? We're not dealing with calculus things, and we're not also dealing with differential equations and advanced engineering mathematics. Okay, so it would be, shall we say, a little bit easy to manage. Okay, the 4 mathematical operations and plus the exponents, something like that only. Okay, so 4 pi squared times s squared times r, which is gonna be 4 pi squared r cubed, or r raised to the power 3. 2 of 1. Guys, if you multiply, you add the exponent. Okay? Like that. And then it's gonna be GMS T. Right? Oh my gosh. T. Sorry, this is T squared. Okay? Nalibat si June. T squared. Be careful also when you derive because, you know, if there's a single mistake, automatically your final derivation formula will be wrong and you have to go back again. It's gonna be the procedure. You have to review again, go back again where you did it wrong. You know, common sense. Okay, something like that. So we have this equation. Okay? Now, there's still coefficient beside GMS. Beside T. We don't want this because this can confuse us. We need to eliminate this one by dividing both sides with GMS. Okay? Like this. So GMS. Okay? GMS. Cancels the GMS because the same quantity. Right? So what will be left will be T raised to the power 2. Okay? Like that, 4 pi squared r cubed over GMS. And this is now our simplified formula of the gravitational force equation in the planetary science in the universe. This one. Okay, so the T here, guys, is the orbital period, time covered in one revolution. Okay, in an orbit, right? For example, the Earth revolves around the Sun in 1 year, 365 days. And then in the leap year, 366 days. Something like that. It's gonna be like that. That is the period orbital time. Okay? Again, period orbital time. Because that's orbit. Okay? And we're basing for 1 year. Okay, so very slow to revolve in a year. And then while revolving is also rotating, something like that. It's spinning. S-P-I-N-N-I-N-G. The spin could either be negative and positive, of course. Okay, if the left negative, if the right positive, if up positive, if down negative. In algebra also, four quadrants, right? If you draw y-axis and x-axis, so there's gonna be also the rotation moment will follow the signs. Okay, positive, negative, positive, negative, positive, negative, rotate, rotate, rotate in the orbit, something like that. And one revolution is equals to 365 days in case of the Earth. But for other planets, I don't memorize, but there are a lot also of values each. Okay? Wala ko yung memorize na mabuang ko. Okay, something like that. Okay, so this one. Now, this formula is applied by Johannes Kepler. By the way, Johannes Kepler and Isaac Newton are having a good relationship as a scientist. After Johannes Kepler discovered the third law of motion in the universe, okay, let's make this clear, class. The law of motion is not only applicable inside the planet Earth. Okay, we have also the laws of motion in the universe, the same as the laws of motion inside the planet Earth, discovered by Isaac Newton, the three laws of motion, right? First law of motion will be the law of inertia. The second law about acceleration, force is equal to mass times acceleration. The third law will be the law of interaction, okay? Such as the free-falling body, something like it's like an apple, it will be dropped in the ground, and there's a gravity, something like that. In the universe also we have three, and this is not discovered by Newton. This is discovered by Johannes Kepler. Okay, Johannes Kepler discovered this, but the data came from Tycho Brahe, okay, a scientist before him. But Tycho Brahe died. Okay, so nobody continues his contribution. That's why this Johannes Kepler continued his contribution by experimenting further and have a scientific laws, and this arrived the three laws of motion in the universe, or what we call as the three laws of Kepler motion. So, if they discovered something, they will carry the last name of that scientist, something like that. So, before going further in the problem solving that I will be introducing to you later, okay, I need to elaborate also, because this equation, guys, this is already the third law. And there's still first law and second law of Johannes Kepler. I go directly with the derivation, but I forgot to discuss to you the three laws of Kepler in the universe. Okay, my gosh. So I need to get the universe, this one in my universe talaga. Okay, this one. Okay, it's gonna one. What is the first law of Johannes Kepler? The first law of Johannes Kepler states that all planets revolve in the elliptical orbit, okay, towards the sun, something like that, having the sun at one side of the foci. Okay, so meaning to say elliptical or ellipse. That's the first law. Okay, the second law will be all planets have a joining line directly pointing to the sun with equal area, something like that, during equal period interval of time. So this is referring now to the orbital time, the t. Okay, something like that. And the third law of Johannes Kepler states that the square root of the orbital time period is directly proportional to the cube root of the semi-major axis of the orbit, or the mean distance of the planet toward the sun, something like that, represented by the letter R. Okay, so this one actually we can derive this in the third law of Johannes Kepler, and then we can also derive to parallel the third law by Johannes Kepler. So how can we do this? Okay, how can we do this like this? So usually, guys, again, in science, okay, we'll never forget the initial states and the final state function, right? Just like thermodynamics, physical chemistry, or in the general chemistry lecture, always repeating like at point 1, point 2, okay? Point 3, point 4. Point 1 will be equal to point 2. Point 2 will be equal to point 3, assuming in a steady state flow, in equilibrium, like that. Assuming it will be going or obeying the law of conservation of energy. Especially here, law of conservation energy will be applied here because all planets have specific energy. And then how can we quantify if we will not equate their energies as the sun is less, something like that. So we need to equate also. So in here, we need to have point 1 also and point 2 in this equation. Okay? Mag-gina siya per sa science. Point 1, point 2, point 1, point 2, point 3, point 4. You will incorporate that in a certain letter for the variable, okay, and then get the individual formula, and then somewhere along the way you can cancel the same thing, and you can come out with a simplified formula. Even though the teacher will never teach you how to do that, by your own, you can create your own formula. Okay, because you can correlate all the basic formulas stacked in your brain cells, then you can have your own formula also. Okay, because they cannot also share to you everything, your professors and instructors. Okay, really, maybe 60% only, 70% only the knowledge. They cannot transmit or transfer all their knowledge to you. Okay, even though you are paying the tuition fee. Okay, and every payment. So you should do by your own. Okay, you should study, go to the library. Okay, at any time T. If you are got confused, okay, something like that. Because some also instructors in college are very brilliant, and then too much, and sometimes you cannot understand really very intelligent instructors because they will never show the systematic way of discussion because they are very intelligent. Okay, then they assume also that the students are very intelligent, also the same as him or the same as her. Then of course the students will get confused. Oh, we're like this, and then nga. Okay, so you have to go to the library and have your own effort to dig it out what's really happening and derive there. Okay, by your own. To be resourceful and have your own initiative. Do not be dependent in your instructors and your mentors in college. They are just only the guidance. Okay, but they are not the one who mold all your knowledge. Okay, something like that. So it's gonna be like this. So how can we do this? Okay, so point 1 and point 2. So since guys, capital really is our standard in sciences also. Capital T, capital P, capital S. Ganun talaga siya. Okay, it's not referring always to small letter. Usually start with capital letters in declaration of the formula. If you can remember, right? Force, capital F, right? Like this. Something like that. Capital P for the pressure. Ganun siya. Okay, so in here also, our small letter T, we will change this to the capital T. Okay? But actually, it doesn't matter. Only the precise way of presenting the discussion. Okay, so capital T squared. Okay, let's just change the small letters to capitals. Okay, so 4 pi squared, capital R cube. Okay, GMS. Now guys, in having a ratio, okay, it doesn't matter guys, really. I proved that already. When I was in college, I never proved that. Just recently I proved, okay? So for example, I tried to research what's this topic in physical chemistry, the Henry's law. If you can still remember for that one, okay, the pressure of the solution is equal to the Henry's constant times the partial pressure of the solvent, right? Now, the basic for that in that scientific law, it states that the solubility of the solution is directly proportional to the partial pressure of the solvent. Diba? Proportionality meaning dependent with each other. When this one will increase, the other also will increase. Something like that, okay? Now, since we are fun with putting one in science or in mathematics, right? P1, P2, like that, V1, V2, all the time, ganun na lang siya parati. Okay, so since solubility is directly proportional to the partial pressure, so I will say partial pressure directly proportional to solubility. So we can have also that one as P1 over P2 is equals to S2 over S1, or is also equal P1 or P2 over P1 is 2 over S1. It's also equal P1 over S1 is equal to P2 over S2. Four equations will yield the same answer really. Okay? I thought it is not like that when I was in college. Because it has the same quantities and properties. Okay? Something like that. Directly proportionality, magod siya. Okay? So, the ratio and proportion. Because, una, mahadlo ko mo baylo. Okay? For example, P1 over P2 is equals to S1 over S. Imo na dyan ginumduman class that if you use P1, and the other side is 1 sa dang mag-una. Okay? Then if you use P2 sa left, S2 sa dang mag-una dito sa right. Kana siya mo yield to the same answer. Okay? But before, when I was in college, I thought it will change the answer if it is reverse. Because the instructor also are telling only one kind or one mode of equation. For example, the equation of the instructors presented in her discussion is only P1 over P2 is equals to S1 over S2. He doesn't also specify there are more other equations also parallel to that. That it could be also P1 the reverse. P1 over P2 is 1 over S2 is the same as P2 over P1 is equals to S2 over S1. Or it could be also P1 over S1 is equals to P2 over S2. O pwede mo siya, ibali na po din mo siya, P2 over S2, and then the four formulas will yield the same answer in ratio and proportion, assuming that the operating parameters, conditions, quantities are similar in quantities. Something like this. We are only dealing with two quantities, which are the solubility and the partial pressure. In here also, it could apply here. Okay, because proportionality also. Okay, as I said a while ago, the third law of Johannes Kepler states that the orbital time period, okay, raised to the power 2 is directly proportional to the mean distance or the semi-major axis of the orbit raised to the power 3 or the cube root of this mean distance. Ganun siya. Okay? So, I could say also in this, guys, that T2 over T1 raised to the power 2. Okay, in here. Okay. Okay, capital naman siya. Ako mag-change of capital. Okay? So, T2 over T1 over T2 na siya. Okay? And then in here also, sa una po di mo siya. Take it individually. So, in here, guys, you know, pi is constant, g is constant, and also mass is constant, in which this is the mass of the sun. We don't put subscript numbering for this. Okay, because the one will always vary is the r, the capital R. So we need to put this as R2. Okay, so 4 pi squared R2 raised to the power 3 over, ganun siya. Okay, GMS. Okay, GMS. Ganon. GMS, mass of the sun na siya ha, ang MS. Okay. We should not put 2 and 1 in the mass of the sun because it's still mass of the sun. There's no other mass. The mass of the earth are already cancelled naman yun siya. So we don't put 2 or 1. Okay? Like this. So over 4 pi squared R1 raised to the power 3 over GMS also. I do not put also GM2 and GM1 because that is constant, the same. Okay, so I don't have to put subscript 1 and 2. We can only put subscript in the R because the R here is variable. Okay, we need to designate a subscript 1 and 2. Now, if you designate a subscript 2 in the numerator, you also designate two subscript also in the left side and the right side to parallel. Okay? Ayaw irambol-rambol. Kung sa imong gibuhat sa numerator, do it also in the other side. Okay, something like that. The same as the denominator. Something like that. We should also designate the same subscript. Okay? So in the denominator, so we have T1. So we also designate in the other side, which is R1. Now, in here, take a look. There's a common already. Okay, so we can cancel out what are common and what are parallel. Okay, so we can cancel 4 pi squared. We can cancel also GMS, the gravitational force and the mass of the sun. Okay, what's left is T2 over T1 raised to the power 2 is equal to R2 over R1 raised to the power 3. Because R2 raised to the power 3 over R1 raised to the power 3 is just the same, each raised to the power 3. So you will also say R2 over R1 raised to the power 3. So it's gonna be like that. So T2 T1 raised to the power 2 is equals to R2 over R1 raised to the power 3. And now this is our final formula. Okay, nga-cancel na tong mga chupa-chucho. Okay, so what's left is only two quantities, R and the orbital time and the semi-major axis of the orbit or the mean distance of the planet towards the sun. Any kind of planets, any kinds. Okay, so this is gonna be our equation. Okay, now if the problem also will state, if we'll try to break down, then break down that one. Okay, using only T2, then we have also T2 formula here, right? Here. So use that one also. Especially if the problem is dealing with mass and this is your equation in the final, and you will be shocked, oh, there's no mass for that. And then go back to the equation where it involves a mass, common sense, okay, something like that. Do not be dependent on the, on the final outcome of your formula. You should also go back, somewhere like that. It's there, something like that. You should be observant in each angle of the derivation, okay, like that. Okay, so ganon siya. So equation 1 and equation 2. Okay? Guys, we are still in the gravitational force in the universe. This is not yet the electric force between electrons and protons in the universe. Okay, let's just stop for a while. Let's take a deep breath. And I'll be back later. Okay, thank you so much. So okay, just copy this formulas in a blank sheet of paper and add this to your to your studies. Okay, because in the future examination or in the board examination, that is always expect the unexpected. Okay, so even though the topics are not really that, we are not studying this, but actually it's studying there, but they're not just going in detail. It's not been touched because, for example, the time is very less, and then the outline, the what do you call this one? The lesson plan, and then there's so much activities in the school, and they cut off some topics. They go only to the major topics that they're able to discuss for their target and the timeline, the major topics for the for the subjects, and other topics also linked to that are not being discussed due to time constraint. So that's really a possibility. Okay, so that's why it's always expect the unexpected, something like that. Okay, it's gonna be like this. Okay, thank you so much for watching this, shall I say a little bit lengthy now, 1 hour and 4 minutes live streaming. This is again, I am a singer, Eternal Voice. You can comment down below in the comment section. If you are not subscribing my YT channel, then you can subscribe if you like. And then you can also click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Okay, it's all about occupational safety and health, pure sciences, a little bit of mathematics, singing, biritan, and also personal vloggings, something like that, or any other else. what comes in my mind. Okay, thank you so much. Bye bye, everybody. God bless. See you later. Oh my gosh.